Well, welcome everybody. I do miss you a lot, and I'm trying this out for the first time. I hope this works for you. The first video was too long. I'm gonna have to break this up into 10-minute segments, and I hope these help you. It's gonna be kind of quick, but you can watch them more than once. The first video is on stoichiometry, factor label, STP and mole equivalents, and percent yield. Coming to you live from the Feeney TV studios. It's just the beginning. The first thing I have is an equation. I have a reaction here, and I put it in red. And you have this propane, C3H8, and you're going to have a combustion reaction with oxygen to form carbon dioxide and water. I picked this one because it has good coefficients. So the first thing you do is you write out a balanced equation. It's very, very important that you do a balanced equation, or else you can't do any stoichiometry. Second is, here's the way I arrange it. I put everything that's not moles up here. If it's grams, they go up here. If it's liters, I put them up here. Next thing you need to know is that you can never go from grams of one reactant to grams of another. Why? Because there's a tree in the way. Yes, it's a chemistry. And you can never go from grams of oxygen over to grams of carbon dioxide because there's a wall. Or even grams of carbon dioxide to grams of water because there's a city in the way. It's probably where bears hang out, Den City probably. Anyway, what I want to do is show you how to do this kind of an easy way, then I'll show you a shortcut in the next video. The first thing I'm going to do is I have to go down in the mole world. Where do moles live? They live underground. So that's why I have all of my moles underground. See, here's the ground. Moles are down here. Now, this is not a limiting reactant. How do I know? Because they only gave me one given. They didn't tell me the given on both of these. So this is going to be an easy one. So the first thing you want to do is you said, let's say, for example, you want to find out how many grams of oxygen. Your plan is go down here, step 1, step 2, step 3. Step 1, grams of propane to moles of propane. Here we are, grams of propane. And what do you know about propane? I wrote some molar masses here that'll help you speed up things a little bit. 1 mole of propane, C3H8, equals 44 grams. Factor label, easy. 2.27, 3 sig figs. All right, the next part is a little tricky. And when you go sideways, now when you're going sideways, you have to pay attention to the coefficients. Now, I didn't do this. God set this up so they'll react in this manner. Notice here that I started out the way I did in the last problem, and this right here changes it to moles. So that should be 2.27. But how do you go sideways? How do you go sideways in the mole world? When you're going sideways in the mole world, you always pay attention to coefficients. And so let's try this. I'm going to go from moles of propane to moles of oxygen. Moles of propane to moles of oxygen. In this balanced equation, for every 1 mole of propane, you have to react with 5 moles of oxygen. That's where I got this. This is called a mole ratio. So whenever you go sideways, you're going to pay attention only to the coefficients. Now, it says how many moles of O2, so that's how I got there. But how do I pop up your moles of oxygen into grams of oxygen? Well, we did that when you got certified. Moles of oxygen, 1 mole of oxygen is 32 grams of oxygen. Pretty easy. There you go. That's how you do that. Let's go down to the next one. How many moles of water are produced? Now, what I can do is if I want to start here, once I get in the mole world, I can go anywhere I want. I can go from here to here, from here to here. I can go anywhere I want. So they want moles of water, so I'm going to go all the way over to here. There we go. Let's try it. So I'm going to start with, I guess I'll start with this one. I'll go from here to here. 11.4 moles of oxygen. Now I'm going sideways again, so I'm going to pay attention to the coefficient. Moles of oxygen, change it to moles of water. All right, here we go. Moles of oxygen. In this case, for every 4 moles of water, it takes 5 moles of oxygen. This is a mole ratio again. You cancel these out, and you'll get that number right there, 9.12. Notice that this number here is always bigger than that number. All right, as a matter of fact, 5/4 times bigger. Then how do you change moles into grams? We did that last time. You're certified in that. That's easy smeezy. There we go. 164.2 grams. Here's something new. What if I want moles of carbon dioxide? Okay, start with any of these you want. Okay, let's say we start with this again. Now we're going over here to moles of carbon dioxide. In this case, for every 5 moles of oxygen, you'll get 3 moles of carbon dioxide. Here's your mole ratio again. That's how you go from moles of oxygen to moles of carbon dioxide. All right, now that right there will give me this number here, 6.84 looks like. Now, how do I go to grams? If I want to go to grams, I can do the factor label from last chapter. That's easy. But here's what's new. How many liters of carbon dioxide at STP are produced? The people who discovered the mole concept did their experiments with gases. And they knew that you had to, if you want to compare gases, they had to be at standard temperature and pressure. So they picked 0 degrees Celsius as their standard temperature and 1 atmosphere of pressure as their pressure. So 1 mole of any gas at STP has a volume of 22.4 liters. You just got to memorize that. You have to. So now you have a new little thing to put in your equivalents. 1 mole of carbon dioxide equals 6.02 times 10 to the 23rd molecules. Carbon dioxide equals 44 grams. And 1 mole of any gas is 22.4 liters. Now I can use any of those I want to make my conversion. So I go down here, and the easiest way to do it, start with moles. Start with moles of carbon dioxide. There we go. And 1 mole of carbon dioxide is 22.4 liters. There you go. All finished. All right, so that's how you use factor label to do stoichiometry. Now, I will be showing you a shortcut in the next video. I'm not done with this one yet. Let's take a look at another one. This one's called percent yield. Percent yield. Now, percent yield is pretty easy. It's actual yield over theoretical. You say, wow, what does that mean? Well, actual yield, you have to actually do the lab, and then you get an actual number, like experimental yield. Theoretical is the numbers I got on this piece of paper. I didn't get any equipment out. All these are theoretical. When you actually do an experiment, you don't get those numbers. That's perfect world. You're not going to get perfect. For the propane reaction, a student actually did this experiment and got 150 grams of water. What did the paper say? The paper said that theoretically you should get 164.2. That's the perfect world. Okay, we're not going to be perfect, so actual percent yield is kind of like how close to perfection you got. Actual yield, they got 150 grams when they actually did it. The theoretical yield, 164.2, that's on paper, times 100. Look at this, 150 divided by 164.2 times 100. Wow, 91.4. That was good. Now, last semester you learned about percent error. What's kind of interesting is percent yield is percent of correctness. What's this? Percent of not correctness. Isn't it kind of neat? 100 minus 91.4. What's the percent error? 8.6. Get it? All right, that's going to end my first video. Stop by the second video, and I'll show you some shortcuts and how to do limiting reactant. Thank you.